Hello, folks. I just wanted to let you know that we are today going to finish up our review of exponents. Again, our goal in this section is to use properties of integer exponents, and then we're going to finish up today by using some scientific notation. So this was your warm-up from Friday. So it's been a little while, but these are the problems that you took some time to complete in class on Friday. You could look over them, make sure they're done. These are the correct answers. If you weren't here on Friday, that's what those should look like. So I'm going to flip through. We took some time to do an activity on Friday that had us exploring some initial properties of exponents. So, you know, if we have like bases and they're multiplied together, we're allowed to add our exponents. As we scroll down here, if you have a quotient with like bases, you're allowed to subtract your exponents. And we even got a little preview that anything raised to the power of 0 will always give us 1. And then we made it official with this chart. We took some time to fill in some examples from page 14 in our book, and we went over them. Keep in mind our negative exponent rule, that there's our upstairs, downstairs rule. So if you have a negative exponent, you always have to work really, really hard to get rid of it. Our 0 exponent rule just says anything raised to the power of 0 is always going to equal 1. Our product of powers rule and our quotient of powers rule were the rules that we worked on in the exploration that show us when we're allowed to add our exponents and when we can subtract them. And then the last couple of rules here are really kind of like distributive properties for exponents. So when you see parentheses, that's going to be your visual cue to multiply the exponents together. Remember, you're allowed to use those three properties as long as there's no plus or minus in the parentheses. So what we're going to do right now is just take some time to review. Here in example 1, we took some time to just remember that -5, if you have that in parentheses and you square it, you actually get positive 25. However, when the parentheses go away, we don't end up distributing that exponent in. Rather, we had to square the 5 first to get 25 and then make it negative. In part C, that's my product of powers rule. So I had 2 to the first times 2 to the fourth. That's going to give you 2 to the fifth, or 32. And then for part D, you had 4 to the fourth over 4 to the sixth. That's the same thing as 4 to the 4 minus 6. We're allowed to subtract our exponents, so you end up getting 4 to the negative-2nd power. And we did mention already once today that you can't leave a negative exponent in an answer. You should have 1/16, or 1 over 4 squared as your final response. So I just wanted to kind of remind you of those. You did some problems like that on your homework. If you had problems with the book work over the weekend, hey, we're doing this a lot more tomorrow when I get back. So we are by no stretch of the imagination done with this section. You're practicing a little bit today in class, a little bit more, gaining a couple more skills, and then tomorrow we're actually going to do a big practice day with our properties of exponents. So if you had questions from Friday night's assignment, by all means, please bring those with you tomorrow and we will spend some time going over them. So now that we kind of glanced over example 1 a little bit, I wanted to give you some time to try a couple on your own. There's an independent practice set through here a little bit, independent practice. And I wanted you to go ahead and take a look at A through D. And now right now it says, you already did A through D, hopefully, but well, yeah, that's because I'm showing and telling you to go ahead and do it now. So what I'd like you to do is go ahead and fast forward a little bit to that independent practice. And I would just like you to try A, B, C, and D. That is you actually taking some time to review your properties of exponents with just numbers. So you could actually check these with your calculator if you have it handy. Whoever your substitute is today probably wants to go ahead and take a minute to press pause on the screen. I think you can also hit spacebar if I understand how this works correctly, and that'll pause it for you. If spacebar doesn't work, you can mouse over the little pause button there and pause the video for the students. I'd like you to try A through D, and then this video will show you the answers in just a moment. Okay, so as promised, there are your answers to your first couple of independent practice problems. For part A, you get negative 81. For part B, you get positive 81. That's because you have negative 3 times negative 3 times negative 3 times negative 3. Negative times a negative times a negative times a negative makes that all positive. You might recall that when you have even exponents, that sort of makes your negative sign positive, but if it were odd, it would stay negative. For part C, I just used my power of product rule, so 2 plus 1 gives me 3 for the exponents, and then 3 to the third is 27. Part D, quotient of powers, you just do 5 minus 8, and then you're like, oh no! You have 3 to the negative third, so you have to move that to the bottom of your fraction to make that 3 positive, and then you'll see that we put that placeholder of 1 there, and then you could simplify it to be 1 over 27. So hopefully that helps you with the warm-up a little bit. All right, so now we're going to take time to do these examples with letters in them. So we're going to flip back a little bit. Sorry, I have you flipping through your note packet a little bit today. We're going to have you flip back to example 2. And it says use the above properties to simplify each expression. So what I'm going to go ahead and do right now in part A is I'm going to go ahead and walk you through how you could simplify this with your properties of exponents. The first thing I see in part A is the ability to use the associative property. I can group those like things together. So for instance, I can rearrange this problem to be negative 3 times 4. And then I could also do the A's, put those together, and then the B's, I could put those together. Now what's nice about doing the problem this way is that I know when I multiply like bases, I could just add the exponents together. Negative 3 times 4 is just negative 12. And then I have A squared. And then B to the 4th times B to the 4th. 4 plus 4 is just 8. So I get B to the 8th there. For part B, when I see parentheses, I always think about using the distributive property for exponents. Notice I can do this as long as there's no plus or minus in the parentheses. So for there, I'm going to go ahead and distribute this 3 into the parentheses. So this is going to be 2 to the 3rd times x to the 3rd, and then y to the 2nd, and then if I cube that, 2 times 3, that there gives me y to the 6th. And then I would want to simplify that a little bit. This is going to be 8 x to the 3rd, y to the 6th. 2 times 2 times 2 is 8, so you want to simplify that. To move on to part C a little bit, what I see right here with the parentheses, because I always go to parentheses first, I'm like programmed with the order of operations. I forgot to circle that final answer there. We'll see here that negative 4a squared raised to the 0th power is actually 1. So I'm taking 3a times 1 in this problem. And you get 3a is your answer there. For part D, just to finish it up with you a little bit, we go ahead and we distribute that 2 into the parentheses. So I'm going to have 5 squared times x to the 6th over y squared. So it's going to be 25 x to the 6th over y squared. So that's that for you. In example 3, it's going to be pretty similar. We're going to rewrite each expression with positive exponents. So if you take a look at that one, I have x to the negative 1st. That's not too bad. That's just our upstairs downstairs rule. So you just write that, move that x to the 1st to the bottom, and then you need a placeholder on the top. So 1 over x is what we get there. Now what I like about this next problem is that it reminds you that only the things that have the negative exponent move. So this problem, writing it as is, looked like this, so I butchered it. This 3 here is actually raised to the 1st power. So the only thing that has a negative exponent is actually just this x to the negative 2nd power. So not even kidding, all I have to move is the x to the negative second. I just move it upstairs. So my answer there is 1x squared over 3, or you could write that as x squared over 3. That's all I had to do. In part C, what I see with the parentheses there is a lot of the distributive property. So I'm allowed to distribute as long as I don't see any plus or minuses in the parentheses, and I don't see either of those things. So I'm going to go ahead and distribute that exponent in. So I get negative 5 to the third power. Remember, it's all of negative 5 that gets cubed, and that's why that's in parentheses there. So all of negative 5 gets cubed, and so does that z there. And then I still have times z squared. But because multiplication is associative and commutative, I could actually regroup the z cubed and the z squared together. And then if I want to take care of negative 5 cubed there, negative 5 to the third power, that's like negative 5 times negative 5 times negative 5. It's going to be negative 125. So what we actually get here is negative 125, and then I'm allowed to add my exponents together for my z's, z to the fifth. And then our last problem, again, I see these parentheses. I'm allowed to distribute that exponent to everything in the problem. All 4 of those pieces need to be squared. Again, I do this because there's no plus or minus in those parentheses. So I'm going to square the 3, square x to the 4th by multiplying 4 times 2. 4 times 2 is 8. On the denominator of this particular fraction, I have x squared that now needs to be squared. 2 times 2 will give me 4. And then y squared squared is also y to the 4th, because 2 times 2 is 4. I'm almost done. One problem with this particular expression right now is the fact that I have x to the 8th on top, x to the 4th on the bottom. You can actually use your power of a quotient rule. I said that backwards, quotient of powers rule, to help you out. So simplify this guy to 9, and then now you know those guys do battle, and x to the 4th would be left over on top, while y to the 4th remains on the bottom. 8 minus 4 gives you the 4 for your power of x. So now you get a little bit of a chance to try. Please forgive me, I did make a little bit of a typo, I think. I do believe that you have seen perhaps E, F, G, and H, maybe. I feel like I did those already today. Maybe just C and D, huh? Yeah, so yeah, those two. You don't need to do these on account of the fact you did them already. So sorry about that. These are typos. Sorry. You don't have to write all that. That's just my apology to anybody who's reading the notes as a PDF file later. Okay, so this is your chance to shine there, kiddos. You have these as independent practice problems. If you want to go ahead and have your instructor, your substitute teacher today, pause the video. I'll go ahead and pull up the slideshow that has the answers on it, and that way you can see how you did. So you can have about maybe 5 minutes, maybe. I don't even know if it'll take you that long. Maybe 4 or 5 minutes to go ahead and do E, F, and then I, J, K, and L. Okay, so see how you did. Part E, you have negative 2x squared times y to the 4th. F was easy. That took you more than 5 seconds to realize, oh my gosh, it's raised to the 0th power. I'd be kind of surprised. That's not to say it didn't happen. Seeing that 0 exponent there sometimes escapes you. But your answer there for part F is 1. Part I there is the upstairs-downstairs rule, so you have 2 over a squared. J is basically 1b to the 5th over 5a to the 4th. For part K, I distributed the negative 1 in. So you have x to the negative 1st over 10 to the negative 1st, but then you're like, oh, negative exponents. So it actually works out to be 10 over x. L was tricky because you had to distribute the exponent in. And once you distributed those exponents in, a couple things happened. First of all, you got some negative exponents. And then second of all, it's in a difficult order. So what you're going to see in my first step is me just distributing the exponents in. Then I took some time to simplify my numeric values. So -2 to the third is just -8. 4 to the negative first, upstairs, downstairs, rule that guy. That's 1/4. I then went ahead and I used that associative property of multiplication to rearrange stuff. So I put my numbers together, and then I put my letters together, and that made the problem a lot easier to work with. 1/4 of 8 is 2, so 1/4 of -8 is -2. And then x to the 6 times x to the -3rd, you're allowed to add those exponents together, so you get x cubed. Okay, last thing we have to talk about today would be scientific notation. And scientific notation is defined as a number, is written in scientific notation if it is expressed as a product of a number n such that that number is between 1 and 10, not including 10, and 10 raised to a power. So my favorite example of this would be, let's talk about the number 62,000. There's a way you could write that in scientific notation, and then there's a way you could mess it up. To show you scientific notation for 62,000, the first thing you have to do is find where the decimal goes. 62,000, that decimal is on the very end of the number on the right side. I now have to move that decimal until I get a number between 1 and 10. Well, if I move it one spot, right now I'm at 6,200, and that's not a number between 1 and 10. Nor is 620. Nor is 62. But 6.2 is a number between 1 and 10. So I know that that's my number part. How many times I had to move that decimal is going to be my power of 10. I moved it 1, 2, 3, 4 times, so that's 10 to the 4th if I just count the bubbles. Now let's say, what would that look like if I messed it up and didn't write it in scientific notation? Well, if I wrote 62,000, not in scientific notation, it might look like this. If I move the decimal point only over 1, 2, 3 places, well, then I'm looking at 62 times 10 to the 3rd. And because 62 is not a number between 1 and 10, that doesn't work out. That's not scientific notation. So our rule, we have 2 parts to our definition. You have to have a number between 1 and 10, not including 10. See that subtle difference there? There's no equal to symbol right there. So it's got to be a number between 1 and 10, not including 10, and then the product of 10 raised to a power. So what we're going to do is 2 things. We're going to take a number that's big or small and write it in scientific notation. And then in the last example, you're going to take something that is in scientific notation and turn it back into a number. Our rule for taking a number and turning it into scientific notation is written there. We're going to move the decimal point until you get a number n such that that number is between 1 and 10, and then count the number of moves that you made. So if there are 359 billion gallons of water on Earth, the first thing I'm going to do is I'm going to write that number out. So there's 359 million, 359 billion. Your decimal point's over here to the right. So I need to move that decimal to get a number between 1 and 10. 11 times is how many times I move that. So this number can be written as 3.59 times 10 to the 11th power. I looked up the population of Westview in 2012 was 6,759 people. So if I wanted to figure out what that number was in scientific notation, I'd move it 1, 2, 3 spaces to the left. This is going to be 6.759 times 10 to the 3rd power. We could also do small numbers in scientific notation. If you had chemistry, you might remember the mole and Avogadro's number. Was it like 6.02 times, well, that was a big number. I can't remember. 6.02 times 10 to the 23rd or negative 23rd or something crazy like that. It was negative 23rd if I remember a mole's small. That's neither here nor there, but my really small numbers, I have negative exponents. So if I have 0.285, that's going to be a small number scientific notation-wise. The first thing I have to do is take that decimal and move it to make a number between 1 and 10. Well, as it turns out, I only had to move it 1 time to the right to make it a number between 1 and 10. 2.85 is a number between 1 and 10. And because I moved it to the right and not to the left, I have to give it a negative exponent. So it's times 10 to the negative first because I moved it one time. In part D, 1, 2, 3, 4. I had to move it to the right 4 times to get it to be a number between 1 and 10. 5.61 is a number between 1 and 10. Because I moved it to the right, it gets a negative exponents. So really small numbers have negative exponents. Really big numbers have our positive exponents. Now we have to take some numbers in scientific notation and turn them into real numbers. So we have 2.1 times 10 to the 4th. What we're going to go ahead and do for this is we're going to move where the exponent tells you. So because this is a positive 4, I'm going to take my decimal and I'm going to make this number bigger. So I need to move it out 1, 2, 3, 4 spaces. And then in those spaces, I'm going to fill in some zeros. So what we actually get is 21,000 for that problem. If I want to take 3.26 times 10 to the negative 5th and write that as a number, a negative exponent makes my number smaller, so I have to move it 5 spaces to the left. 1, 2, 3, 4, 5. And then I fill it in with zeros. So this is going to be 0.0000326. So see how it's a smaller number with a negative exponent? And then 1 is like 1.0 times 10 to the negative second. So I move that 1, 2 spaces to the left. So what I have there is 0.01 as my answer, 1/100th. Okay, so now you get to try. So your instructor is going to hit pause one last time and go ahead and give you rather a second to try these independent practice problems out, and then I'll go ahead and show you the answers. You can keep in mind this video is on Blackboard, so is the PDF file. So if you need to see something again or review it, or if you aren't here today like me, you can go ahead and view it on Blackboard. Okay, so there's your independent practice conclusion questions. You do have bookwork for tonight. It is on the assignment sheet. I did leave the lesson plans with the sub. You're going to give those a try. So you're going to add a little bit onto Friday night's assignment. And then we are going to go over all your homework questions and do a little bit more practice tomorrow when we get back together as a class. So do the best you can on the problems, and I will gnash out any issues you had with this lesson when I get back in tomorrow. So hang tight, and we'll see you later.